Just to continue my methods, just to explain a little bit more about what I did, because this slide is going to really carry along the rest of the presentation. For my variables from those 2 days, the first set of variables were my predictor variables. I used predictor variables such as the recovery heart rate from the step test. So that number, abbreviated herein as HR. Also, I used the maximum number of push-ups performed. That's a predictor variable. Those are the 2 fitness-associated variables. The response variables here, we've got the heart rate response to 10 minutes of CCO, CPR. I did that. I affixed the heart rate strap to each participant at 1-minute intervals throughout the 10 minutes of chest compressions. I recorded the heart rate over 1-minute intervals. 10 values divided by 10. I got an average snapshot of how difficult it was in terms of the heart rate response for the 10-minute trial CCO, CPR. I also did a lactate response assessment following the bout 4 minutes after to get peak concentration. And then also I obtained, this is interesting, this was first done in 1992 by a researcher named Pierce, published his findings in the Journal of Motor Skills and Perceptual Motor Skills. And what they did was, for their CPR study, and this is where I got the idea, they used 3 different domains for RPE. For those of you that don't know, ratings of perceived exertion is how subjectively difficult the exercise is. You can say from 0 to 10 or from 6 to 20. 6 being easy, 20 being difficult. But I read a script to them prior to this. 6 to 20, how difficult was it for you shoulders and arms? 6 to 20, how difficult was it for you chest and breathing? And 6 to 20, how difficult was it for you overall? The statistics, the primary assessment here was stepwise multiple regression. I completed that on R for math. The statistical significance was set at probability is less than 0.05. My regression analysis, this is my hypothesis here, I believe yielded a model that accurately predicted the values of the response variables. So in more informal terms, using these predictor variables, I think that I could predict these variables. So by obtaining how many push-ups somebody did, I'm trying to see, based on that number, how you will respond in terms of your heart rate. So if you did 10 push-ups, I can use a regression equation that will tell me what your heart rate response to this should be based on the data. And I've got enough sample size to do that, because you need only about 15 per predictor, and I've only got 2 predictors, 47 participants.
You know what is the ratio of predictors and independent, I should say, what is the ratio of dependent variables and independent variables if you want to run the linear regression?
I don't understand your question. I use each of these, I use both predictor variables in a stepwise fashion for each response or dependent variable. So I ran more than one multiple regression model. So
I think what he's saying is how many for each, if I understand what you're asking, what...
Because when you run the multiple regression, there is a ratio there. One dependent variable should have 5 independent variables.
One dependent variable?
One dependent variable, which is predictor there, should have at least 5 independent variables.
Well, that's more of a matter of taste, because you can do multiple regression with 2 to 4 predictors. That's you would, from my understanding from the literature, one need not have more than 5 independent variables for one dependent measure.
But there is a ratio there. If you don't do that, you can lose it.
So we could touch on that in the end here. That's what I did. What did I find? Let's just go through the chart here. I'll stay on this side. This is my chart. This is the table. This is my guts and glory here. Okay, looking at the table, push-ups. Total push-ups for everybody doing the push-up test, 21. Again, that's for 47 people, 33 of which were females, 14 of which were males. 33 females, 14 males, for a total of 47. Average push-ups, 21. Interestingly, the females did significantly less push-ups than the males. They did 14, the males did 38. Recovery heart rate, so there's a gender difference. Gender differences were detected for push-ups, I just explained that. Recovery heart rate, the 3-minute step test that I remember I obtained that recovery heart rate. The average was 134.5. There was no gender difference for the recovery heart rate. Also very interesting. That's point number 3. The recovery heart rate was not significantly different between genders. So there is an upper body muscular endurance difference, That's probably related to the cross-sectional area of the upper body muscles. But aerobically, my subjects were identical. Males and females were not significantly different from one another. That's interesting. Moving on down, that's the fitness assessment. Going to the 10-minute CPR trial. The heart rate response for all individuals for the 10 minutes was 126 beats per minute. That's exercise. That's low to moderate intense exercise. That's a light swim. That's a very low jog. That's exercise. Doing CPR is exercise. Females, so all was 126. Females, 133. Males, 110. Males responded much lower than females did in terms of their heart rate. Lactate response, 2.7 millimoles per liter for everybody. Females, 2.9. Males, 2.3. Males had a lower lactate response. RPE local muscular, 6 to 20, how difficult, shoulders and arms. All subjects, 12.9. Females, 13.5. Males, 11.6. Significant gender difference for RPE local muscular. RPE central, how difficult was it for the subjects to do CPR for central factors, their breathing, their heart rate, and their chest? 10.9. For males, it was 9.4, and for females, 11.5. Right here, RPE difference, there was a gender difference for the RPE. RPE overall, 12.9. For males, 11.7, and for females, 13.4. Again, overall was gender different. There were gender differences. This is another interesting point here. Point number 4, RPE central was significantly lower than RPE local muscular and overall for both genders. Our subjects during the CPR bout, they don't really feel it fatiguing in terms of their chest and their heart rate. They don't feel fatigue, generally speaking, in their chest and their heart rate. It's local muscular factors that they rate the highest. That's significantly higher than the central ratings. And the last point here, just to touch back on this. So CPR, by and large, for our subjects was more difficult for females. It was more difficult for females despite the fact they had identical aerobic fitness levels. What was different about our subjects? They had different upper body muscular endurance levels. So maybe doing chest compression CPR and keeping your heart rate and physiological and perceptual responses low isn't a question of whether you have aerobic fitness. Maybe it's a question of how anaerobically or how much local muscular endurance do you have in the upper body. That's the difference in our cohort. Some more figures here. Over here on the x-axis, I've got the max number of push-ups. This is for both genders combined, n equals 47. As push-ups went up, the heart rate response to chest compression only CPR went down. That was a significant relationship, probably less than 0.01, with an R of negative 0.45. You do more push-ups, your heart rate's going to be lower during chest compression only CPR. Over here, you have the recovery heart rate from the step test. As your aerobic fitness declines, as your recovery heart rate goes up, your recovery heart rate to chest compression only CPR goes up. That relationship was significant at a probability of 0.001, R equals 0.54. Aerobic fitness, anaerobic fitness, they're both correlated to the heart rate response to doing chest compression only CPR. This can be a lot for the average viewer to take in. I'll kind of go through it patiently. Stepwise multiple regression table. I kind of highlighted just the models for the males and females, just to emphasize the whole group. So, assuming that my audience understands what multiple regression is, I'll just explain to you my findings. My response variable being the heart rate response, using the two predictors, recovery heart rate and push-ups. The strongest predictor for all individuals was the recovery heart rate. That predicted the heart rate response to a greater degree than push-ups did. The lactate response, the model was not significant. I didn't find significance, but at a probability of P equals 0.09, which is a trend towards significance, it looks as though push-ups is a stronger predictor of the lactate response to chest compression like CPR, which makes good sense. What's going to be really buffering lactate accumulation? Local muscular factors. And that's, so as push-ups go, the number of push-ups goes up, lactate response goes down with an R non-significant, negative 0.25. The three RPEs. Okay, RPE, local muscular. For males and females, the strongest predictor was push-ups. Push-ups drives the perceptual response to this in terms of how difficult they feel it to be. Push-ups, push-ups, push-ups. Significant R is Pearson's correlation coefficient, negative 0.43. RPE central factors, again, push-ups. Significant model for males and females. I have a Pearson's correlation coefficient of negative 0.45. Overall, same story. Push-ups is the stronger predictor of the two. The predictors, again, being push-ups and recovery heart rate. And I have a Pearson's correlation coefficient of negative 0.39. So just generally for the perceptual responses to this chest compression only CPR, the more push-ups an individual can do, the less perceptually difficult it's going to be for them throughout the entire 10 minutes. That's for both genders. Never been done before. What's the conclusion? The conclusion is that physical fitness does in fact mediate the physiological and perceptual responses to chest compression only CPR, suggesting that rescuer fatigue is a controllable phenomenon. How do you control rescuer fatigue? You encourage individuals to do fitness routines, stay fit. What's the grand takeaway? In real-world settings, lay rescuers who have poor upper body muscular and or cardiorespiratory endurance may reduce the likelihood of survival for out-of-hospital sudden cardiac arrest victims. So your poor fitness may be the reason your grandpa don't make it. Questions? Yeah.
Can you go back to the heart rate response in the result section? Did you report the resting heart rate?
No.
So can you go back to the male and the female heart rate response?
This?
So yeah, you look at there, the female heart rate response average is 136. The male heart rate response is 130.
Right.
But you did not report the resting heart rate. So you may need to calculate percent change in heart rate in order to use a percent change to run the linear regression with the 10 minutes of compression, like the heart rate response.
That's a good point.
Because you didn't report the resting heart rate response, how can you run the how can you run the linear regression with the heart rate response during the compression?
We instructed every participant, obviously it was a standardized process. We instructed no alcohol, no exercise, tobacco, or caffeine. So we try to control for the extraneous influences of those types of factors. So to answer your question, it's a good point. We try to minimize that as much as possible to standardize this value between the two, and that's what we did.